Hello, 8th grade. Today we are going to be working on finding the least common multiple. The least common multiple, what that is if we have two numbers, let's say 3 and 2, the least common multiple is going to be the number that both of these can multiply up to, and it's going to be the smallest number that both of these multiply up to. And for 3 and 2, that's going to be 6, because 3 times 2 is 6, 2 times 3 is 6. So our least common multiple for that example would be 6. And the good news is there is a very easy set way to make sure that we get the least common multiple. So I want us to look at this. It says the first step is to take a factor tree, write down all the factors from both of the numbers, and then to cancel out duplicates. So what I'm going to do is I'm going to start with two numbers. We'll do this in red, and our two numbers are going to be, for an example, 24 and 36. So the first step says I'm supposed to make a factor tree of these. 24 becomes 8 and 3, 8 is 4 and 2, 4 is 2 and 2, that's prime. 36 goes to 3 and 12, 12 goes to 3 and 4, 4 goes to 2 and 2. So I have my factor trees. So now I'm supposed to write down all the factors from both the numbers. So from my 24 right here, I have a 2, a 2, a 2, and a 3. From my 36 right here, I have a 3, a 3, a 2, and a 2. I'm just going to draw a little line between these. Let me make that a little more clear. A line right between those two sets. And what I do now is I look at my first set and my second set, and I want to cancel out any duplicates that I have. So for my first set, I have a 2, so I do not need a 2 over here. I have another 2, which lets me cancel out another 2. This 2, I don't have anything to cancel out. And from this 3, I can cancel out that 3 right there. So now looking at my factors, the factors that I'm left with are 2, 2, 2, 3, and 3. So that goes there, and I'm just going to bring those along. And those are the factors I'm going to use. All I have to do now is multiply those together. So 2 times 2 is 4, times 2 gives me 8, times 3 gives me 24, times 3 is going to give me 72. So 72 is going to be my least common multiple there. And I got that just by multiplying together all these factors. That led me to 72, which is the final answer. So if we have more than just two numbers, we can do it the same way with the same process. So we'll try another practice problem, or our numbers we're working with are 11, 12, and 18. And again, I'm going to start with a factor tree. 11 is just 11. 12 is going to give me 2 and 6, which is then going to give me 2 and 3. 18 will give me 3 and 6, which is going to give me 2 and 3. So writing all these down, I have 11, 2, 2, 3, 3, 2, 3, just like that. So I'm going to separate these one more time. And going through looking at this 11, there's nothing I can cancel out from it. Looking at this 2, I can in fact cancel out from this 2 right here. From this 2, there's nothing to cancel. Already looked at the 11. From this 3, I can cancel out one of the 3's here. Then I have this 3 here, and there's nothing left to cancel. So, looking around now, my factors are going to be 11, 2, 2, 3, and 3. So I multiply these together. I get 11 times 2 is 22, times 2 is going to be 44, times 3 is 132, and times 3 again is going to be 396. So 396 is going to be our least common multiple. And you get that by multiplying these numbers together right here. That would be the least common multiple of the three numbers 11, 12, and 18. So if we keep on going, now we have to do it with algebraic expressions, of course. So with algebraic expressions, we're going to do the exact same thing. Algebraic expressions. And this will become very useful in the future when we do more complex factoring and all those things. But first, what I want to do is just try a problem using our same algorithm as last time, so the same process as last time. And what I want us to find the least common multiple of is going to be 10 a to the fourth c to the fourth. Sorry, the problem I have written down here is 10a squared c to the fourth. And the other one I would like to find is 15 a cubed c cubed. So I'm going to start by saying this is equal to 10 times a squared c to the fourth. 10 becomes 5 and 2. This becomes a squared times c to the fourth. A squared is a times a. And c to the fourth, of course, is going to be c times c times c times c. So over here, I can have 15 times a cubed c cubed. 15 becomes 5 times 3. This becomes a cubed times c cubed. And now a cubed is a times a times a. And c cubed is c times c times c. And that is a lot of factor treeing, but that's all right. I'm going to write down all these factors. From the first one, I have 5, 2, a, c, 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 c. Draw my line in the middle. And from the second one, I have 5, 3, a, c, c, c. I'm going to work down the line just like I have in the past. So this 5 here cancels out the 5 on the other side. There's nothing for the 2 to cancel out. This a can cancel out this one. This a can cancel out a second one. This c cancels out this c. Another c is canceled. And a third c is canceled. This last c has nothing to cancel. So now I'm going to look at all of my factors here. And I get 5, 2, a, c, 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 3, and a. That's a lot of factors, but we're going to multiply them all together. I'll start with the coefficients here, so I'm starting with just the numbers. 5 times 2 is 10, times 3 is going to be 30. Start with that. I have 1, 2, 3 a's. A times a times a is a cubed. And I have 1, 2, 3, 4 c's. C times c times c times c is c to the power of 4. And that is going to be my answer, which I hope is less complicated than it seems. I know that this involves a lot of weird trees and canceling out, but at the end of the day, none of these are terribly hard processes. We're just multiplying some things together at the end here. So we're counting how many a's we have, and we have 3 a's, giving us a to the third. We have 4 c's, giving us c to the fourth, and then we multiply together those 3 numbers, and we are done. So now I want us to work on using 3 monomials instead of just 2, so that last problem we used 2 monomials. What if we have 3? And we'll try 6p squared s cubed, 2m squared s squared, and 8m cubed p. So from this first one, I have 6 times p squared s cubed. This becomes 3 and 2, p squared s cubed, p and p, s, s, s. And I know I'm rushing through these, but I'm hoping we can all make factor trees at this point. Squared, s squared. So notice my first step is always to break apart the coefficient from the variables, then separate the variables from each other. And then I just write down the number of letters that are in the exponent. It's going to be 4 times 2, 2 times 2, and just like that, I am done with my 3 factor trees. That is a lot of factor trees, but that's okay. We'll keep going in the problem. So from my first one, my factors are going to be 3, 2, p, p, s, s, s. Draw a line. My second one, I have 2, m, m, s, s. Draw another line. And my third one is going to be 2, 2, 2, m, 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 p. And now I can go through and start canceling things out. So this 3 has nothing it can cancel. This 2 can cancel this 2 right here. Moving on, this p cancels out this p. This p doesn't cancel anything out. I'm sorry, looking at this 2, it should have canceled this 2 from this one and the 2 from this one. So you can cancel from one or both when you're canceling out like this. This S right here cancels this. S cancels again. S has nothing to cancel. M cancels here. M cancels here. So I want to go back and look at this 2 one more time just because I know I fumbled on that a little. So this 2 right here, knowing that we have a 2 in this term, means we can take out a 2 from this term and from this term. So if you can cancel out from one or both when you're going through one at a time. Continuing through, I have all these terms in the last part. So now I know we're going to have 3 times 2 times P times S, 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 M, M, 2, 2, M. And now we can just multiply these together. 3 times 2 is going to be 6, times 2 is 24, times 2 is 48. I have 2 P's, that's P squared. 3 S's is S cubed. 3 M's is M cubed. And just like that, I have my least common multiple of those 3 monomials, which is kind of crazy, but that is all right. That should be the end of what we're working with today. We discussed how to find least common multiples not only of numbers, but we also talked about how to find them of a couple monomials, and at the end here, how to find the least common multiple of 3 monomials. So please make sure you do the lesson practice at the end of your notes, and I will see you guys when you are in class. Toodaloo.